Good day. Welcome back to lesson number 5 on graph interpretation with nature of roots. In the previous lesson, we looked at the 3 cases. So let's now look at our first problem. In this example, they say that the following sketch shows the graph of fx equal to x squared minus 4x plus 3. And you will notice the drawing. There's my parabola. The x-intercepts are given to us. The y-intercept is given to us, as well as the turning point is given to us. Now, the first question is, how many roots does fx equal to 0 have? So you remember from the previous lesson, I spoke about this fx equal to 0. This refers to the roots of a function or the x-intercepts. So when we have fx equal to 0 and they ask for how many roots, then it means they want to know how many x-intercepts. And you agree that that is quite clear. There will be 2 roots for this problem, as you can see from the drawing. In the next question, they say that if f of x plus p is equal to 0, as 1 negative root and 1 positive root, determine the values of p. Now you will notice that at this point in time, if you look at this parabola, that both roots or x-intercepts are positive. This question says to us that they want 1 negative root and 1 positive root. And this fx notation, the f of x plus p, refers to a horizontal shift. So to know what x will be, we need to shift this parabola horizontally, and we're going to shift it to the left so that this x-intercept at x equal to 1 will be on the negative side. So you agree it's quite clear we need to move it more than 1 unit to the left. But important, we can't move it more than 3 units to the left, because then this x equal to 3 will also become a negative root. So it is quite clear that we need to move more than 1 but less than 3 horizontally. And the unknown that we are looking for is that x plus p, which refers to our horizontal shift. So what will the values of p now be? And we can say 1 will be less than p will be less than 3. So it means p will be greater than 1. So we need to shift the graph more than 1 unit to the left, but less than 3 units. So please take note, we don't say 2 because we only need to move more than 1 unit. Right, the next question. For which values of k does fx equal to k have 2 distinct real roots? We want 2 roots here. Now fx is my parabola. Equal to k means that is a horizontal line. And we also spoke about that in the previous lesson. So that horizontal line, we can draw it on this graph, and we call it then y equal to k, because it's a horizontal line that intersects the parabola. So this horizontal line that intersects the parabola. So when you look at this horizontal line, think of moving this line up and down. If I draw this horizontal line, this one, right at the turning point, then right here, then you will notice there's only one solution because the line will only touch the curve. So that means equal roots. If we draw the line below the turning point, then it means there are no points of intersection between this horizontal line and the parabola. So therefore, no real roots. If we draw this line anywhere above the turning point, like this one, up here, doesn't matter where, as long as we draw it above the turning point, then we will have two distinct roots. It means two different roots. And they ask us to find k, for which values of k. So let's write down the answer. So this k must be greater than -1. I just want to make sure that you understand why we say k must be greater than -1, is because the turning point, the line at y equal to -1 is at the turning point, and we must draw this horizontal line above x equal to -1. So that means that k must be greater than -1. Right, let's look at the next problem. So let's look at number D. This question say, for which value of p does x squared minus 4x plus 3 equal to p have equal roots? Now this x squared minus 4x plus 3 represents fx. So they can also say fx equal to p, or they give you the fx function equal to p. And we want to know where the roots are equal. That is very important, the equal roots part. Now, like we said in the previous lesson, we will get equal roots right at the turning point. So that fx equal to p means we're going to draw a horizontal line. And the question is, where must we draw it? And we must draw it at the turning point. In the previous one, we said we must draw the horizontal line above the turning point. Then we will get two distinct roots. If we draw it at the turning point, we will only get one root. So we're going to draw the horizontal line right at the turning point, and this will be the line y equal to p. And the question is, what is the value of p? And I think it's quite clear that the value of p will be -1. And we can write it down that p will be equal to -1. Please take note, it can't be greater than -1, because then we get two roots. It can't be less than -1, because then we get no roots. It must be equal to -1. In the last question, number E, they ask for which values of t will x squared minus 4x plus t be equal to 0 have non-real roots. So please take note, they say non-real. So we already spoke about two distinct roots. Two distinct roots, that's when we draw the horizontal line above the turning point. One root or equal roots at the turning point. And now they ask us for non-real roots. And that is when we draw the line below the turning point. But let's just look at this given function before we find the solution. In this function, they say that x squared minus 4x plus t is equal to 0. Because we want to use the graph to find the solution or solutions, we're going to say 4x equal to minus t. So I'm going to move the t to the right. And now I'm going to add 3 on both sides. And as you can see, we now have the parabola on the left-hand side. So now we changed it to the same form as in number D, the parabola equal to a constant. So we have the parabola equal to a constant. Only difference is, instead of this is only a p or a k, this is now 3 minus t. But we still do it exactly the same way. So for these non-real roots, we must draw the line below the turning point. So that means we're going to draw the line right here. This will be the line y equal to 3 minus t. Now, where must we draw this? We must draw this line below the turning point. So this horizontal line must be less than -1. Because if it is equal to -1, we have equal roots. Above -1, we have two distinct roots. Now we have non-real roots when we draw it below the turning point. So how do we write it down? We're going to say that 3 minus t, that is now that right-hand side that you can see, that 3 minus t, must be less than -1. And now it's just manipulation. So minus t is less than -4 if we move the 3. And then we divide by a -1. So we say t is greater. Remember, when we divide with a negative, the inequality change. And t will be greater than 4. So as long as t is greater than 4, we're going to get non-real roots. Thank you.